So guys, today we come around in a question of internal combustion engine, where it is given that the following data is where a single cylinder of 4-stroke oil engine having bore diameter of 350 mm and stroke length of 500 mm and speed of 400 rpm and indicated mean effective pressure is 6 bar and net brake load 1.7 kilonewtons, brake drum diameter 1.6 meter and brake rope diameter 2.2 centimeters. So first of all, we have written the given data here. According to that, here I have written the indicated mean pressure in pascals, the stroke length in meters. Everything I have converted from mm to meter to the SI units, and the brake load is given as 1.7 kilonewton. Rope diameter, it is also converted into meters, and the brake drum diameter is also given as 1.6 meter. First of all, I want you guys to visualize the question here. So what the question is says that the brake drum diameter, yes, the brake is given by a drum in which a rope is attached like this. This is the rope above which the drum above which the rope is in contact with like this, where the drum diameter is 1.6 meters and the rope diameter is 0.022 meters. The total diameter of this thing will be diameter of the drum and diameter of the rope. So let's go to the calculation part, how we can find the indicated power, brake power and mechanical efficiency. So for indicated power, yes, for the indicated power we have the expression Pm LA N, or we can write it as a small n, blank by 60,000. It is in kilowatt. As you can remember like this is a blank. Remove the m, that is you can remember like it's a blank by blank by 60,000. Okay, so here we'll put the values. The mean indicated mean pressure is like what is here is 6 into 10 to the power 5. Everything will be written in SI units here itself. 6 into 10 to the power 5 into the stroke length. It is stroke length is 500 mm, that is 0.5 meter. Area will be the cross section area of the cylinder, where the cylinder is in a cylindrical shape. Yes, the cylinder is like that. So the cross section will be this part. It will look like a circle, the cross section. So the cross sectional area of the circle will be pi by 4 into, yes, pi by 4 into the bore diameter, that is 0.35 whole square, into the n, that is n. As it is a 4-stroke engine, the speed will be divided by 2, that is 400 rpm divided by 2, and the k is the number of cylinder, that is 1, and it is the by default here, and the value will be, what will be the value? Is calculated as 96.16 kilowatt. So it is the indicated power. Is the indicated power. Then we'll calculate the brake power. For brake power, brake is given by which thing? Brake power is given by the torque itself. The torque is given giving the brake 2 pi nt by 60, or you can write as 60,000. Okay. or in kilowatt, you can write 60,000. This is the single torque to brake power formula for everything you have studied in I think theory of machine itself. This is the formula that is applicable to all for power calculating from torque. Hence, it is the power required to break the wheel, so break the drum. So it is called as brake power. So let's put the values here. The speed will be 400, and torque. That is the torque. Yes, we need to calculate the torque here. Torque will be what? Torque will be what? Torque will be nothing but the omega into diameter of the diameter of the drum. Yes, diameter of the drum plus diameter of the rope divided by 2. Okay, that is will be the torque. That is load into distance. Okay, so therefore brake power will be 2 into 3.14 into 400 to pi n t. Torque will be W into diameter of the drum, diameter of the drum plus diameter of the rope divided by 2. This two cancel, and the W is given by 3.14 into 400. The W is given by 1.7 kilonewton into diameter of the drum will be 1.6, 0.022, 60,000. This will give you a result of 57.72 kilowatts. So the brake power will be 57.72 kilowatt. Okay. So now we need to calculate the mechanical efficiency. We know mechanical efficiency is equal to brake power by indicated power into 100%, and we calculated the brake power as 72 and the indicated power as your 96.16 into 100%. That will give us a percentage around 60%. So the mechanical efficiency will be 60%. So all the data, all the given conditions are found out, like the indicated power, brake power, and mechanical efficiency. Hence, this is the solution. If you got any idea and love the solution, love the technique of approaching the question, you can comment. Usually comment as general, and if you like and got if you like the video, you can share with your friends and do subscribe, please.